Okay, we are back again. I want to explain one point for our prizes. We are offering free pass tickets for OpenStack, future OpenStack summits, but the next Open Infrastructure Summit that will be held on October will be free to everyone. And we are offering these tickets for the later Open Infrastructure Summits, and hopefully they will be a physical one. So you can follow our Twitter profile to have a chance for winning that free pass tickets. Our next speech will be AMD EPYC redefining modern data centers from Alexey Nechuyatov, AMD. Alexey Nechuyatov has joined AMD in May 2019 as a technical marketing lead for EPYC-based systems and solutions. His background in international product marketing, HPC, and service business development with companies like Dell, AMD, and Intel. Ladies and gentlemen, please welcome Alexey Nechuyatov from AMD.
Thank you, Dr. Chaduk. A pleasure to be here today, everyone. It's a new format for us this year, and I hope that you find it effective. I'll take about 20 minutes of your time to speak through what EPYC platform is and how we see that today. So in terms of the overall flow of my presentation, what I want to bring you through is really where the company is today in terms of the data center business and how we position EPYC platform for you to take advantage in both software-defined infrastructure and standard server business. And so with that, let me set the stage by saying that AMD is really growing through a very fast growth, and it's really, I'm thrilled to be with the company. I actually witnessed the Opteron years. I was dealing with Opteron business development in Eastern and South Europe, and was on frequent occasions to Turkey, to Istanbul and Ankara. And so this time around, I really see the company really executing extremely well. We are going, actually, we are now in double-digit figures in terms of our client and server market share. There is a very consistent roadmap execution. We are reaching our milestones for both client and server products. And if you look at AMD today, it's really, it is uniquely positioned in the sense that we have both high-performance CPUs and GPUs. And there are three tiers of business that I would probably mention, which is CPU business, GPU business, and also anything which is embedded, ranging from industrial subsystems over to set-top boxes and entertainment systems as well. And so I have to say that the last quarter, Q2, was an extremely successful one for us. We went actually 26% year-on-year growth, and we're almost $2 billion in revenue today. So really, it's about our operational excellence as a company that actually now using foundries to produce different chips. We can concentrate on microarchitecture. And so our time to market in terms of the used production nodes is really amazing. We have a technology leadership that allows us really to offer real world benefits in terms of the various applications and workloads. And we collaborate with customers quite a bit. So our x86 products are really quickly taken into production environment. In terms of the workload scenarios and targeted workloads, we really concentrate on 5 tiers. We are historically present in high-performance computing. We are seeing a lot of traction in anything which is containers and virtual machines, so anything like mega data centers, hyperscalers, as well as local classic hosters, all those teams that have technical excellence and have enough expertise in-house, they quickly see the benefits in terms of the massive rollout of EPYC-based server infrastructure. Hyperconvergence is a strong theme this year. We see a lot of OEMs launching their hyperconverged appliances and certified nodes. In memory, we are seeing strong growth there as well. Machine intelligence, I belong to the CPU business unit, and our platform provides an extremely scalable way to host different GPUs, whether it's from AMD, Instinct line, or NVIDIA. And so anything in terms of AI, ML, DL, we definitely see traction there as well. In order to make sure that our architecture and hardware is implemented quickly and brought to production environment, we work with our ecosystem partners, both with ISVs and OSVs, with hardware partners, and with OEMs and ODMs as well. The idea is really to ramp up the number of certified and tested components, applications, and operating systems to the market. Needless to say, we are an x86 supplier, so absolute most of software is going to work right off the bat. Obviously, using some compilers, you can take extra advantage and get your performance higher up. So I've already touched on the key tiers of market that we approach. Cloud, I would start with cloud. And back in 2017, when we launched our first generation EPYC CPUs called Naples, we've seen companies like AWS, Microsoft Azure launching their instances. Oracle Cloud also joined the race. Later on, we've seen Google, which, by the way, has launched recently confidential VMs based on our security stack integrated inside our EPYC CPUs. We've seen IBM cloud platform as well, adding their instances and bare metal based on AMD EPYC high-frequency CPUs. And so this is one of the key areas where we see strong growth, and COVID-19 obviously accelerated this business because of work from home, VDI instances, and online collaboration. People are buying a lot of cloud-based instances to run their infrastructure securely and in a scalable way. Supercomputing. We now have 2 out of 3 exascale systems in planning phases based on EPYC CPUs. These are El Capitan and Frontier. They're basically a CPU plus GPU platforms, heterogeneous, and we see a lot of both academia, state, and commercial companies launching us in automotive, in weather forecast, in pharmaceutical, lots of tiers of business. Naples was not as successful as Rome because it did not have balanced performance across different tiers of workloads. It has pretty high memory bandwidth, so CFD and weather forecast kind of workloads really profited from running on EPYC first generation. But we really see a renaissance of EPYC with the second generation because it has very strong floating point performance. It has double the cores. And it has very high performance per thread as well. So we see a lot of announcements there. Enterprise is our key focus as well. And compared to 2017, when we just had around 20, 30 platforms in total, it's now talking 140 in 2020. We see enterprise customers launching their on-prem and off-prem instances in absolutely different verticals. But the way we approach this market is really by targeting horizontal workloads because they are pretty much present in each and every vertical market. And so in terms of the enterprise, I would just mention a few. It's things like banking, retail, because our Java OLTP-based workloads are run extremely fast on EPYC platforms. It's anything which is dealing with encoding, whether it's real-time encoding and broadcasting, things like encryption. And obviously, I would also mention oil and gas, pharmaceuticals, and some other segments as well. But basically, the teams that require either higher performance or better TCO story evaluate us today and already deploy. And so with that, let me just go into nitty-gritty, into some details and tell you about the EPYC platform. What really defines us is pretty much 4 pillars. It's either high computational density because of the 64 cores that we can offer, or high performance per thread because we have a few new CPU models that offer extremely high performance because of the high frequency and large level 3 cache per core. All our CPUs actually are hosted on a strong scalable platform with Infinity Fabric, and this allows us really to offer 4 terabytes of memory with each and every CPU SKU with 8 DDR memory channels running at DDR 3200 actually speeds. Both single and dual socket servers, and we don't offer 4-socket systems because our computational density is already high, and the platform is allowing us to offer an extreme amount of I/O lanes, even with a single socket. So both single and dual socket platforms offer up to 128 PCI Express lanes, Gen 3 and Gen 4. Is backwards compatible with Gen 3. And so with that, obviously, a lot of you are dealing with software-defined and storage, I gather. So this is an extremely interesting platform because you can always take, the lowest end EPYC CPU with just 8 cores and still, get access to all technologies that are present. There's a key feature stack there that actually is present with each and every chip. So 128 PCI Express lanes is also, offered both with a single and dual socket AMD platforms. So there is a lower TCO, and depending on which kind of software you have or which kind of scenario, we see, TCO advantages like through the 3-4 year cycle, up to 50%. And obviously an integrated security stack is something very important for us as well. We believe we have a leadership there that allows us to actually work with the OSVs and ISVs and set the stage in terms of where the industry goes next. And so just, to back up my words, there are different core counts. It's a very dynamic range of CPUs in the single socket called SP3. We keep this socket from 2017, and we go into support this socket with our next generation Milan chips. And as you see, there are quite a few models, but the story is really simple. You choose between core count, frequency, well, TDP, obviously, the thermal design power, and maybe level 3 cache. All the rest is always coming inclusive. And we have also a single socket models that are aggressively priced. They have exactly the same kind of features. But to give you an example, if we're looking at the retail 64 core parts, and we compare a 7702P, which is a single socket model only, it's basically $2,000 less than the retail price compared to its dual socket capable part. All the rest of technologies is pretty much the same. And so we, since second generation launch, it's called named EPYC Rome. We launched it on August 7th, 2019. There are now over 170 world records claimed by our OEM and ODM partners. Interestingly enough, more than half is claimed using single socket systems. And it's not about just having all these announcements and victories. Rather, it's a good marker and indication of where the platform is performing well. So I encourage you to visit AMD.com and just Google Epic World Records to see the results sorted by categories of workloads or by partners. And in terms of the real world performance advantages, we really see a very broad spectrum of applications taking advantage of Epic platforms, ranging from HPC and virtualized environments over to containers and databases. And so I'm going to be time to time today at my virtual booth. Ping me if you want to get an animated deck comparing time to result versus Intel Xeon 8280. Most of the time, we compare our 64 core versus that chip. And so, yeah, it's quite interesting to see what we can bring to the table, in terms of the high performance or better TCO. To give you a hint of how we approach different workloads today, there are two distinct subfamilies, if you will, in our second generation Rome CPUs. One is 7002 series, and the other has letter F, 7F-X2 series. And so there are just three chips available today from April timeframe this year. We really target low-threaded classic software, which is not optimized for multi-threaded workloads or operation, better put, or workloads that are applications that are licensed per core. And so the idea is that you want to reduce the number of cores but still attain the highest performance per thread. And this is these three chips that we now announce now ship as well. In terms of the multi-threaded apps, it really depends on what your scenario is. You can just go with 8, 12, or 16 cores, or you can go higher up to 48 and 64 cores. But the higher you go, the more you need to look at how much of a scale up you get, of how much memory bandwidth you need to feed all these cores. We see customers often looking at 32 and 64, 48 cores, CPUs to strike a balance between having higher core counts and at the same time feed them with enough memory bandwidth for those applications that take advantage of it. And so the idea is, if you look at our boost frequencies with the highest frequency CPUs, these three models that I referred to, the boost frequencies are pretty much similar. And by the way, AMD boost frequencies work in a way that all cores kick above 3 gigahertz, like 3.2 gigahertz, unless there is a temperature above 95 centigrade TKs. And so for the workloads that are integer dependent and not utilizing vector instructions, you can expect the CPUs to operate at higher than base frequency range. Obviously, things like power, things like cooling, things like the application itself, really go into effect the overall frequency range. But yeah, long story short, do not look at the base frequencies, for as long as you don't run lean packet and any kind of HPC applications. And that's one of the reasons we get this high performance, because, it's really about the platform. We have this Infinity Fabric with up to 18 gigabit transfers per second to scale, core-to-core and socket-to-socket communication. We have this huge cache of up to 16 megabytes of level 3 cache with these three specific models, there's two of them, to really fetch data and reduce the traffic on the bus. And the micro architecture itself is very different from our competitor. There's a high IPC, and it's really a modern architecture that we designed with security in mind as well. And I'll talk about it in a bit. And so one of the value propositions that we are bringing to market is is really about our single socket platform. Because if you look at what we are offering today is the ability to still, get a lot of cores inside one socket platform. It's going to have a smaller footprint. It's going to consume 150 to 200 watt less power. And it offers the performance of dual socket competitive systems. And so this combination, this choice of either having higher compute density with a lot of cores or targeting, highest performance per thread is giving you a range of scenarios that you can utilize. One of the things that people do not realize is that using single socket platforms also reduce latencies. Actually, our latencies on single socket, despite the disaggregated chiplet architecture, is lower than the competitive dual socket systems. And so definitely, if you start approaching AMD platforms, take a hard look at the single socket systems first, because the only reason you would want to have dual socket is really having more memory. Yes, we address 4 terabytes of memory, but sometimes you just need to have access with fewer cores to a larger memory footprint, and that's when the dual socket systems might make sense. Some of the platforms actually offer also more than 128 PCI Express lanes. The way we do that is because the fabric is quick enough. Some OEMs and ODMs actually take coherent fabric lanes and reroute it to the I/O subsystems. So there are up to 162 lanes at the end of the day. So you can connect things like 8 full height, full length GPUs directly to CPUs. And in terms of the NVMe and SATA lanes devices that we support, it's up to 32 SATA devices, it's up to 24 NVMe devices, and we're talking a platform without any PCI Express switch. So the latest is that you get.
Sorry, we have the time and we have 4 questions.
Okay. Yeah, sorry, got taken away. So the last slide would be that we have on Silicon security stack. And so this is really about secure multi-tenancy. So you have VMs cryptographically encrypted by the secure processor, which is an ARM chip inside our silicon. And so we also are able to encrypt all DIMMs with a single 128 encryption key. So there are over 510 encryption keys that can be used for both physical and virtual deployments, DIMMs and VMs. And there is no application impact, there is no recompilation needed, and there is pretty much no performance hit as well, because everything is integrated close to the memory controller subsystem. So with that, let me say that next year you'll see our Milan 3rd generation chips available, and most of the OEMs and ODMs are going to support it with the current systems. It really up to them to offer something new or just continue with the current infrastructure. And having said that, we are, as a company today, delivering on promise. We are executing in a predictable way, reaching all our milestones. There's a leadership performance in terms of both computational density and per thread performance. And we enjoy pretty strong ecosystem support. So with that, I'd like to thank you and answer the questions. Okay. Is there any reason why server manufacturers offer limited AMD CPU configurations? Well, it's up to server manufacturers. I guess they just it's a validation standpoint, and it's their costs, operational costs. So it's their policy, but it really depends. A lot of manufacturers offer almost the entire range of CPUs. So The market share of EPYC server CPU, we are not directly claiming it. We're saying that we are now in a double-digit market share. So IDC would be your reference, I guess. Our internal calculation show that we probably passed 10%. I would say our largest customer using OpenStack, well, hyperscalers. I'm not going into details. Some of them are public, some of them are not. But today, if you look at the top largest mega data centers, a lot of them work with EPYC infrastructure. Does AMD support CPU level RAID options? This is a question that our competitor is always pitching. It's very popular, though we really pitch different thing. No, the CPU level RAID options are not available in EPYC. What we offer instead is a very high performance PCI Express subsystem with low latency and large amount of devices connected.
Okay, thank you, Alexey, for your presentation.
Thank you, and sorry for being out of time.
Okay.